Before the first ball is bowled in a cricket match, the umpire flips a coin to decide who bats first. Why do we trust a coin to be fair? Because we intuitively understand the math. You have a 1 in 2 shot, one specific side you want to see out of 2 possible sides that could land. That simple idea, comparing what you want to happen against everything that could happen, is the starting point for every calculation we're about to do. Probability is just a way of turning that intuition into a precise fraction so we can accurately predict how games work. We can take that coin toss and write it as a fraction. In math terms, the top is called the favorable outcome, and the bottom is the total possible outcomes. Think of the bottom number as the big picture, every single scenario that could happen. For a coin, that's just 2, heads or tails. The top number is much more specific. It's the one winning result you're looking for. Since a coin only has 1 head, your fraction is 1 over 2. These fractions live on a scale from 0 to 1. If a probability is 0, it means the event cannot happen, like rolling a 7 on a standard 6-sided die. On the other end, a probability of 1 means it is certain to happen, like the sun rising. Every probability you calculate today will land somewhere between those 2 points. Let's test our fraction on a die. If you roll it once, what are the chances of landing on an even number? First, we find the bottom of our fraction by looking at the big picture. Since a die has 6 faces, there are 6 total possible results. Now we look for our winners. The even numbers are 2, 4, and 6. That gives us 3 favorable outcomes for the top of our fraction. When we put them together, we get 3 over 6. We can simplify that down to 1/2, which means you have the exact same chance as a coin flip. Now let's try a deck of 52 cards. This is often where students get stuck, but the rule doesn't change. To find our total possible outcomes, we just look at the whole deck. There are 52 cards, divided into 4 suits and 2 colors. 52 is our bottom number. This exam question asks for the probability of drawing a face card. That means any card with a person on it. If we pull out every king, queen, and jack, we can see there are exactly 12 of them. Those are our favorable outcomes. Our fraction is 12 over 52. If we divide both by 4, we get 3 over 13. Even with 52 cards, the math stays simple. Sometimes a problem gives you a probability and asks you to find its opposite. Take this match between Geeta and Ritu. We're told Geeta's chance of winning is 0.27. Remember our scale from 0 to 1. Since winning or losing are the only 2 options, their probabilities must add up to exactly 1. To find the chance that Geeta loses, we just subtract her winning chance from 1. 1 minus 0.27 is 0.73. This logic works on more than just games. We can use it to analyze the letters in a word, too. Take the word Delhi. To find our total outcomes, we just count the letters. D-E-L-H-I. That's 5 total options for the bottom of our fraction. If we want to find the probability of picking a vowel, we look for our winners. The vowels here are E and I. That's 2 favorable outcomes, giving us a final answer of 2/5. Whether it's cards, dice, or letters, you are always just comparing what you want to see against the total number of possibilities. When you face a probability question, just ask 2 things. First, how many ways can I win? And second, how many total things could happen? Divide the first answer by the second, and you have your probability. If you want to double-check your work, just make sure your final result is a number between 0 and 1. This fraction allows you to see the likely outcome of a game before the dice hit the table. You're ready for the next chapter.